Welcome dear students, we are on the CEC Gurukul lecture. We are in the series of the electronic circuit, and in this series we discuss the many electronic components. In the today's lecture we discuss the new component, that is the memristors. Memristors are just having the two words and formed from the two words like memory and the register, and it is similar to the resistor but with memory, means we are having a resistor but it is having a memory. So resistor with the memory is known as the memristors. So the memory resistor memristor is a passive two terminal solid state non-linear electrical component that are used in the electronic circuit. Whenever just we have to save or memorize some value, so we use the memory resistors, that is the memristors. Beside resistors, capacitors and the inductors, the memristors is considered as a fourth fundamental element in the electrical circuit. Like resistor, capacitor and inductors, we also use the memristor, and which is a fourth fundamental element in the electrical circuit. The capacitor, resistor, inductors are the three basic passive element, and that every electrical engineer is familiar with it, and they are called the fundamental element because they cannot be built with a combination of any other. So as these are independent and the passive because they do not need an external power supply to function. That is why they are the passive elements. And the memristor can remember the electronic state and represent it using the analog signals. In a circuit of this type, when we talk about the circuit of this type, makes it possible to produce the computers with instantaneous ignition, like without it being necessary to reload the operating system at each start. So the circuit retains information even without an electric current when the computer is turned off. Means the memristors can retain the information even without an electric current when the computer is turned off, and that will, when it is turned on, then we will use that memorized term. The possibilities of sorting analog signals makes it possible to store and process a quantity of data much larger than that processed by the digital circuits, which is capable of representing all in the two state like 0 and 1, but this memristor can capable to store the large data as compared to the digital circuits. So the memristors is a new generation of memory and computing power device. So this is the symbol of memristor. You see here that there is a square wave type of signal and it is enclosed in a box. This is the signal. What is the history behind the memristors? In 1971, memory register theory introduced by the Leon Cho professor, which is of the California University, and he described it as an electrical passive element which is named as a memristors. So what is the principle behind the memristors? The memristors regulates the value of electrical flow corresponding to a datum according to the history of the voltages applied to them. This means data can be stored and processed simultaneously in the memristor devices, and it makes the memristors much more efficient than legacy system. So memristor can store the data and that data can be processed simultaneously in the memristors. Dynamic electronic devices are typically passive electronic component that work exactly like a variable register to manage the data storage. So This memory memory register means memristor is a dynamic electronic devices, and that can dynamically store and change the data. Similarly to the resistors, it executes and maintains a safe current flow through a device. Also remembering the last change it passed. It means the memory register can execute and maintain the safe values in the device, and also remember the last change it is processed. So a resistor differs from a ordinary resistor because it is remember charges even when no current or the voltage is present. So one of the advantage of this memory resistor is that it is different from the ordinary resistor, that it can remember the charges even when the no current and voltage is present. Therefore, the information can still be stored even when the device is turned off. When it is turned on, then we can recall that value or that process. Now, what is the working, construction and working of the memristor? The memristor is a two terminal devices. The resistance of this element depends on the polarity, duration of the time and the magnitude of the voltage applied. The resistance of this element depends on the polarity, duration of time and the magnitude of the voltage. You see on the screen, this is the construction of the memristors. Now, it is having the platinum electrode on both the side. In between that there is a doped TiO2, and right hand side there is a undoped TiO2. One is variable and the length is approximately 3 nanometers. So, this is the construction of the memristor that is used in the electronics devices. Take a resistive titanium dioxide as a memristor element. We use the titanium dioxide just to construction of the memristor's element. So, this material is placed between the two electrodes that is made of the platinum. You see here all the the doped and undoped TiO2 is placed in between the platinum electrodes. Now, the internal section of the titanium dioxide divided into two parts. One part is the doped with the titanium dioxide and the second is left is undoped. So, when we apply a voltage across the electrode, the oxygen atom present in the titanium dioxide start diffusing. When we apply the voltage across the electrodes, the oxygen atom present in the titanium dioxide starts diffusing, and the direction of the oxygen atom diffusion depends on the polarity of the applied voltage. So, the diffusion of the oxygen atom cause to change in the resistance of the doped portion of the titanium oxide. In this manner, we can get the to existence of the fourth passive fundamental element. Now, you see here that there is a 3 are attached, the 4 is memristors are on the right hand side on the in the circuit. There, although the memory resistors always flow the fundamental circuit and the variable of the voltage, current and their time integrals. So, they have a dynamic function with the memory and can be described as a net load function. The same is not found in the 3 other fundamental circuit elements like resistor, inductor and capacitor, but in this memristor there is a dynamic function with the memory that can be described as a net load function. So, memristor is also capable of logical functions. So, this can be significantly change the current compartmentalized structure of computing, as this allows the creation of the devices capable of both the processing and the storing data in the same space. So, it works as a logical function also. Currently, there is no standard memory registers, but each device implement a particular function. In such a case, the voltage integral determines the current integral and vice versa. So, we can have the current integral and the voltage integral, we can determine if we have the one. What is the characteristics of this memristors? As you see on the screen, that characteristics voltage and the current VI of the memristors. Now you see current and voltage. An important demonstration of the memristors is its characteristics, VI characteristics. And here we are having the hysteresis curve for a memristor excited by a periodic signal such as a square sinusoidal. So, here this is a loop that define the IV characteristics of the memristors. Now, for a memristor turned on by the periodic signal square or sinusoidal, it can be seen from the above figure, as we see that when the voltage is 0, you see here when the voltage is 0, the current is also 0 and vice versa. So, the voltage and the VI current comply with the identical 0 crossing. You see here on the screen, you see that in between current and voltage there is a loop and both the loop are connected, and there is a point 0 0. When the current is 0, voltage is 0. So, there is a relation between the voltage and the VI current comply with the identical 0 crossing. Now, if we see the memristor is a two terminal passive circuit element that has a non-linear relationship between the electrical charge and the magnetic flux connection. Now, you see here it is a non-linear relationship between the electrical charge, that is Q, and the magnetic flux phi connection. Now, it can be seen from the above figure that the charge slowly becomes 0 as the magnetic flux phi axis. You see here the 0 crossing at the point, we are having a phi and Q 0, but it is a non-linear distribution. How many types of memristors? We define the memristor are classified into the several types based on their design, and overview of these types is given below as well. We classify the memristor into two categories. Memristor in two categories. One is a molecular and ionic thin film memristor, molecular and ionic thin film memristor, and second is the spin and magnetic memristors. One is a molecular and ionic thin film memristors, and second is the spin and magnetic memristor. So, now you have seen on the screen the type of memristor ionic thin film and the spin and magnetic. Further, it are divided again in the many parts like titanium dioxide, ionic and tunneling diode, and there are the different type of the molecular and ionic thin film memristors. Now, in the spin we are having the spintonic and the spin torque transfer type of memristors. Now, molecular and ionic thin film memristors, and molecular and ionic thin film memristors depend on the different properties of the material and the hysteresis initiation in the material after incorporating change in it, like titanium dioxide. If we talk about the titanium dioxide, this is one type of the molecular and ionic thin film memristors. So, in this type of memristor, it is having a titanium dioxide as the main element, and the hysteresis in this memristor happens due to the transfer of the oxygen between the layers after its charging. When we are charging, then there is a transfer of the oxygen in the titanium dioxide. In case of the ionic, the ions are of two types. One is an ion and second is a cation. The ion, when in the solid state, has a capacity to move a charge, and it can move the charge from one place to the another in any direction. The hysteresis in the material can be developed by dynamic doping, and it has a single passive layer in between the electrode and the polymer as an active material. In this ionic membristors, so there is a single passive layer in between the electrode and the polymer that is an active material. So the polymer forces the ions, and as a result it moves from the electrode to the film. So its function on the principle of the electrolyte processing. The polymer, because the polymer forces the ions and they move from electrode to the film. It is like a electrolyte processing. Next is the magnetite. Now, in the magnetite is a similar in the construction and functionality like the titanium dioxide, and in the magnetite, in place of the titanium oxide, a film of magnetite oxide is used. So it is almost similar to the titanium dioxide. In place of the titanium dioxide, a film of magnetite dioxide is used. A resonant tunneling diode, that is another type of the memristors, and it utilizes the multiple quantum well diodes, and multiple quantum diode wells or multiple quantum well diodes, and therefore it can be utilized dynamic doping and generate the hysteresis among the film layers. So this is the type of the this is the first type of the memristor. In the another type, that is the magnetic effect and spin technology. Here we define the degree of freedom technology. So development of this type of memristor, where we talk about the magnetic effect and the spin technology, then it is based upon the degree of freedom technology. The polarization of the spinning electron can be controlled by the magnetic field created by the moving magnet. In this type of magnetic effect, we use a magnet, and when the magnet moves, the magnetic field created and that used to control the spinning of the electron, and thus hysteresis is generated. In this manner, we can this memristor work. Next, which is also the important one, most important one, and nowadays we work on it, that is a spintronic. The spintronic technology is similar to the titanium dioxide memristors. In this type of memristor, one can change the direction of the spinning electron by using a movable magnet. Means we can change the clockwise and anti-clockwise or any direction at an angle. We can move the spinning of the electron by using the magnet. As a result, this hysteresis generates between the devices, and that we can trace. Next is also important, that is a spin torque transfer. Spin torque transfer, it means torque produced because of the spinning. Now that is a MRAM, magneto-resistive random access memory, is a memristive component by the nature. So the hysteresis is generated by the spin valve technology and of the MRAM. The spin valve technology varies the resistance, and as a result the current is induced through the junction made up of the magnet, and in MRAM inherently has a magnetic and ionic characters, both used in this spin torque transfer. and this magneto-resistive random access memory, the hysteresis is generated because of the two factor, one is magnetic and second is the ionic character. The three terminal memristors designed with the three terminal using the electroplating technology. In this type, when we talk about the generation of the memristor, so this memristor is designed with the three terminals, which is using the electroplating technology. The non-solid state generates the hysteresis. The time integration of the current controls the conduction of the system. So, what are the advantages of the memristor devices? Memristors have the many advantages, like it uses memristor uses power when the device is active, similar to the non-volatile memory. Therefore, memristor require the less energy to operate. And the next, memristors produces less heat and they are faster than the current technology such as SSD memory. Memristors are less expensive. They can store twice as much data on the same surface. Memristors are intensive to radiation like the transistors. And in other advantages we have, they provide the non-volatile memory. Memristors can prevent computers from needing to be rebooted. The user would find his files and his application in the state where he had left them. So means no data will be damaged even if the computer is off. This would allow us to reboot a PC as quickly as we turn on the light bulb. And what are the disadvantages of the memristors? Since memristors are still in development, their future depends on determining the best hardware implementation. The speed and the performance of the memristors are not as per with the speed of DRAM and the transistors. The memristors are not commercially available. And in the other application of the memristors or the uses of the memristors, there is a potential. It can be used as a switch and it is possible to connect the multiple inputs and the outputs in the matrix. So, it is called it is used in the matrix switches also. In the PLC devices, it is used as a signal processing. In the super resolution imaging, it is used, and memristor are used in the physical neural networking system, and in the control systems we use the memristors in the control system, in the digital circuits, in the biological and neuromorphic systems. We use the memristors. Computer and networking technology. In computer and network technology, we use the memristor. So, memristor is generally used to where we just use the registers with the memory, then we use the memristor, which is insensitive to the radiation like the transistors, and it also provide the non-volatile memory, and memristors can prevent the computers from the needing the reboot. And so there are many application of the memristor other than other devices, more than that of the digital devices. We use the memristor, and this memristor produces the less heat, and the current technology can store the memory. Data can be retrieved easily when the computer is switched off. So, they can store twice as much data as the same surface, and it is having having this memristors is made up of the three terminal like electroplating technology, on the base of the electroplating technology, and the non-solid state generation generate the hysteresis. We define the VI characteristics in the form of the hysteresis in the memristors. So, time integration of current controls the conduction of the system is there in the memristor. Like the other passive devices, memristors can be dynamic, and it can work on the different values also. So, in this manner we define the memristor, and this memristor device is generally used in the electronic circuit. In this in the various type of memristor, spin tonic are generally used. Now it is which is similar to the titanium dioxide, and that can change the direction of the spinning electron by using the movable magnet. Means when we change the position of the magnet, then we can change the movement of the electron as it is spinning. So, as a result, the hysteresis generates between the devices, as the because it works on the magnet. As the magnet moves, and the spinning of the electron can be adjusted, and that output can be taken as hysteresis generation curve. So, another type of as we discussed, another type of the memristor, that is also the spin torque transfer, and this spin torque transfer, the current is induced through the junction made up by the magnet, and it is only because of the varies of the resistance. And the spin valve technology used here, and the MRAM inherently has a magnetic and ionic character in the spin torque transfer. Thank you very much.